Hi everyone, this is Miss Eisenberg here with you for lesson 19.1a, central angles. We're going to kick this off with the definition of a central angle. Let's go ahead and highlight that. So a central angle is an angle formed by two radii. Radii is the plural of radius. So by two radii meeting at the center of a circle. So right here we have angle AOB. That is called a central angle. You can see that the two sides of the angle are each radii, they're each a radius. From O to A, that's a radius, and OB would also be a radius. And O is the center, and that's where the sides meet, and that's called the vertex of the angle. So we can call angle AOB a central angle, which I will do. And then a really important fun fact about that angle is that the measure of that angle, so the measure of angle AOB, and of any central angle, is equal to the measure of its intercepted arc. So that would be equal to the measure of arc AB. And like I said, that's true of any central angle. So the angle measure, I'll write that in words, is equal to the measure of the intercepted arc. Okay. We're going to use that property to solve for some unknown arc measures, angles, and variables in this lesson. So let's start with example 1. They want us to find the measure of arc AB and then the measure of angle AXB. So let's start. I'm going to get a few different highlighter colors going on here just to kind of differentiate. Let's start with the measure of arc AB. So that's this arc right here. Okay, so I'm going to start with what I know, which is that a full circle measures 360 degrees. And then we've been told that this arc here is 210 degrees. So measure of arc AB, which is the leftover arc of the circle, would just be the difference between the full circle, so 360 degrees, and that arc, which is 210 degrees. Okay, and so when I subtract 360 and 210, I find that the measure of arc AB is 150 degrees. And I want to write that out in a statement. So the measure of arc AB is 150 degrees. Be careful not to drop your degrees on any of your answers here. Okay, and then the next thing we've been tasked with is to find the measure of angle AXB. And that, of course, is this angle here. Well, what kind of angle is that? Notice that the sides are radii, and they are intersecting at the center of the circle. That's the vertex of the angles at the center. So this is called a central angle. Just a different color. So this is called a central angle. What do we know about that central angle? We know that the measure of that angle is going to be equal to the measure of its intercepted arc. So I know that the measure of angle AXB is going to be equal to the measure, its intercepted arc is arc AB. And we just found the measure of arc AB, and that was 150 degrees. So I know that the measure of angle AXB is 150 degrees. Okay, so now I want you to go ahead and try these two your turn problems on your own. So start with number 1. Find the measure of angle XOY in this circle. Okay, so we are looking for this angle, XOY. That is a central angle, and its intercepted arc is arc XY. So I know that the measure of angle XOY is going to be equal to the measure of arc XY. So I know the measure of angle XOY is equal to 91 degrees. Okay, for the second one, we've got a circle. We have been told that this angle is 107 degrees. This is H, this is O, and this is P. And the directions ask you to find the measure of arc HP. Okay, so you're looking for this arc here, arc measure. That is the intercepted arc for angle HOP. So I know that the measure of arc HP is going to be equal to the measure of angle HOP, which we were told was 107 degrees. So I know that the measure of arc HP is 107 degrees. So example 2 asks us to solve for x given that the measure of angle AOC is equal to the expression x plus 40 degrees. Okay, so let's talk about this. AOC is this angle right here, and yes, you guessed right, that is a central angle. And what do we know about central angles? Their measures are equal to the measure of their intercepted arc, and we've been told that the intercepted arc, AC, is equal to 100 degrees. So that means that this angle measure of x plus 40 must be equal to 100. So to solve for x, I'm just going to subtract 40 from both sides. And I'm getting x equals 60. And that is not 60 degrees, that's just 60 because x is just a variable in this expression which has the degree sign on it. So x is 60. All right, let's look at the example. Let's first find the measure of arc QS. So I'm going to highlight arc QS. Okay, so that's what we're trying to find the measure of. All right, well, the first thing that I'm going to recognize is that angle UPT is 47 degrees, and that's a vertical angle with QPR. So I know because of vertical angles that this is also 47 degrees, and I'll write that down. So the measure of angle QPR, 47 degrees, because of vertical angles. Alright, what else do I know? I know that, let's see here. I know that this whole arc from R to U, that is a semicircle. So that means that that arc is a semicircle is equal to 180 degrees. So to find this missing piece right here, I'm just going to subtract 47 and 55 from 180. So I know that the measure of arc RS is going to be equal to 180 minus 47 minus 55, since this piece here is a semicircle. So when I do 180 minus 47 minus 55, I get 78 degrees for this angle and also for this arc. Since they're central angles, they're going to be equal to their inscribed arcs. So this guy is 78 degrees, so I can put a 78 degrees there. Okay, and now to find QS where I've highlighted, I'm just going to add 47 and 78 because once again, these are central angles, so that means their arcs will also be equal to those measures. So 47 plus 78 will give me the measure of arc QS, which is 125 degrees. That's not the best Q. Okay. Alright, and then now we're supposed to find the measure of arc RQT. Okay, so RQT, I'm going to highlight out here, is that whole lovely business right there. Okay, now I could find this missing arc measure here, just subtract the rest of these from 360, get this guy, and then add all of these together. That's one way to do it. Instead, what I'm going to do is I'm just going to take 360 and subtract this piece from R to T, because if I get rid of that, then that will leave me with RQT. So if I subtract the arc RT, I'll just be left with RQT, and that will give me my measure of RQT. Measure of RQT, yes, that's what I said. Okay, so the measure of RQT would be equal to the full circle minus RT, which would be 78 plus 55. Or you can just subtract 78 and subtract 55. So 360 minus 78 minus 55 is equal to 227 degrees. Okay, so I'm going to turn my page now for example 4. Okay, so given this picture, we're asked to find the measure of angle XOY and the measure of angle XOZ. And I just want to remind you that none of these pictures are drawn to scale, so if you're kind of like, it doesn't look like that measure, I apologize. I'm doing my best here. Okay, so we're starting with angle XOY. That's this angle over here. Okay, so the first thing I want to point out is these arc measures we've been given. We know that their angles will also be equal to those measures because these are all central angles, all of their vertices and at the center there. So I know that this angle is 135 degrees. I know that this angle is 29 degrees. So anyway, just wanted to fill that in. Now something you should notice is that XYK here, that is a semicircle. So that means that whole thing is 180 degrees. So to find arc XY, we would just subtract 180 minus 135. So the measure of arc XY is going to be 180 minus 135. Once again, please keep in mind, not drawn to scale. And that is 45 degrees. Wow, that picture is horrible. I'm so sorry. So I know that this arc is 45 degrees, and if the arc is 45 degrees, so is the angle, since that is a central angle. So I can write that the measure of angle XOY is 45 degrees. I'll just leave a little note because it is a central angle. All right, now we are looking for the measure of angle XOZ. So XOZ, that's this guy over here. Well, he is all that's left over from 360. So to find that guy, I can just subtract 360 minus 45, 135, and 29. So the measure of angle XOZ equals 360 minus 45 minus 135 minus 29, which is 151 degrees. All right, I've got a your turn here. Given this picture, first find the measure of arc HG. So, where is H? Oh my goodness. This is supposed to be an H right here. I didn't finish labeling my letters. I am so sorry. Okay, let's try that again. Your turn. Find the measure of arc HG. Alright, so this is arc HG right here. What do we know about what we have so far? I know that this arc would be equal to 90 degrees since the central angle there is a right angle. I know that this arc would be equal to 23 degrees, once again, because of a central angle. So 180 minus 90 minus 23, because this whole thing is a semicircle, tells me that arc HG is 67 degrees. Just keep in mind, not drawn to scale. Okay, and then try number 2. Find the measure of arc FEH. Alright, well FEH is that arc there, and you'll notice that it's this 23 degrees plus a semicircle. And how much is a semicircle? The semicircle here is 180 degrees. We know that because it's a semicircle. I'll write that down. Okay, so to find FEH, I'm just going to add that 23 on to the 180 that we already know. And that gives us 203 degrees for the measure of arc FEH.